Okay, so once again, our topic for this about introduction of data mining. So data mining is a process used by companies to turn raw data into useful information. So by using software to look for patterns in a large batches of data, business can learn more about their customers to develop more effective marketing strategies, increase sales, and decrease costs. No? Data mining depends on effective data collection, warehousing, and computer processing. Again, data mining is the process of analyzing a large batch of information to discern trends and patterns. No? So data mining programs break down patterns and connection in database on what information users request or provide. So I think everybody knows and everybody has your own social media account. No? Social media companies use data mining techniques to commodify their users in order to generate profit. So this use of data mining has come under criticism lately. Users are often unaware of the data mining happening with their personal information, especially when it is used to influence preferences. No? So let's say, for example, if let's say in your Facebook account, you look into, let's say, for example, a hotel or even a good resort, no, or a beach, no. Then later on, you're going to then right after a week or every let's say another week or another month, most commonly your Facebook account show or display a lot of beaches and so on, no. Because data mining, where data warehousing and mining software programs analyze relationship and patterns in data based on what user requests. Let's say, for example, a company can use data mining software to create classes of information. So to illustrate, imagine a restaurant wants to use data mining to to determine when it should offer certain specials. No? So it looks at the information it has collected and create classes based on when customers visit and what they order. So in other cases, data miners find cluster of information based on logical relationship or look at association in sequential patterns to draw conclusion about trends and consumer behavior. So again, warehousing is an important aspect of data mining. Okay? Again, because as what I mentioned, warehousing is an important aspect of data mining, because warehousing is when companies centralize their data into one database or program. So with a data warehouse, an organization may spin off segments of the data for specific users to analyze and use. However, in other classes or even in other cases, analysts may start with the data they want and create a data warehouse based on those specs, or specifications. So regardless of how businesses and other entities organize their data, they use it to support management decision-making process. Now, a while ago, I mentioned about data mining in social media, because one of the most lucrative applications of data mining has been that of social media, because platforms like Facebook, of course owned by Meta, TikTok, Instagram, and Twitter gather realms of data about individual users to make inferences about their preferences in order to send targeted marketing ads. So this data is also used to try to influence user behavior and change their preferences, whether it be for a consumer product or who they will vote for in an election. Let's say, for example, in TikTok, you are always using about Marcos. So automatically, when you open your TikTok once again, so it could display more on about Marcos. So when your TikTok, when you open your TikTok, you are always looking for Ivana Alawi. So automatic next time when you open TikTok, most commonly, more TikTok video from Ivana Alawi. Same, let's say, for example, you wanted always to watch a video about Lenny Robredo. So automatically, next time you open your TikTok, so it's about Lenny. Okay? So, data mining in social media has become a big point of contention with several investigative reports and exposes showing just how nefarious mining users data can be. Okay? Excuse. So, again, grocery stores, to give you an example, grocery stores, no, most commonly, no, a while ago, no, before I will give you about the data mining or about the grocery, no. So, a grocery stores are well-known uses of data mining techniques. Now, let's say, for example, based on the result of, let's say, if the grocery uses a, what do you call this one? Yung ginagamit nilang cash register, no, parang ganon. Many supermarkets offer free loyalty cards, no, to customers that give them access to reduced prices not available to non-members. So, the cards make it easy for stores to track who is buying what, when they are buying it, and what price. So, after analyzing the data, stores can then use this data to offer customers coupons targeted to their buying habits and decide when to put items on sale or when to sell them a full price. So, most commonly, sale happen, no, every cut-off, no, every salary period, no, 15/30 or I think 20 and 5, no? So, data mining can be a cause for concern when a company uses only selected information, which is not representative of the overall sample group to prove a certain hypothesis. No? Again, data mining processes are used to build machine learning models that power application, including search engine technology and website recommendation programs. No? During your capstone project, let's say, for example, I will assign as a panel, I'm looking forward on how you'll be able to build, no, your database. So what will be, is there any search engine wherein I could able to use, let's say I'll just want to search this one for me to generate a report for this one and so on and so forth. No? So, because data mining relies on big data and advanced computing processes, including machine learning and other forms of artificial intelligence or AI. The goal is to find patterns that can lead to inferences or predictions from otherwise unstructured or large data sets. Actually, if you were enrolled in data mining and data warehousing, you need also to be good in statistics, no? So data mining also goes by the less used term knowledge discovered in data or the KDD. No? So who uses data mining? Data mining applications, okay, range from the financial sector to look for patterns in the markets to governments trying to identify potential security threats. So a corporation, and especially online in social media companies, use data mining in their users to create profitable advertising and marketing campaigns that target a specific set of users. Okay? So actually, there is a problem, you know, when it comes to maybe if your proposal accepting, let's say for example, your capstone or your thesis accepting, let's say for example, online payment. So the next question of the panel will be, how about the security? Do you have a two-way authentication and so on and so forth? How do you have a do your system be able to text or to send me as a SMS or even an email if somebody open or wanted to use my account and so on and so forth? These will be the possible questions that could able to raise by the panel. So you need to be ready. Let's say, for example, you are proposing an online and especially online payment. It's too critical actually when it comes to security. No, I will show you a video. No, about an introduction of a what you call this one, data mining. Okay. Again, before I forget, if you have some questions, if you want to have some additional inputs, no, do not hesitate to post your question in our chat box. Then later on, I will address all your queries and I will read your concerns or additional inputs later, right after our discussion. Again, you are always encouraged to put your questions or clarification in our chat box. Okay.
And examples. When we think of mining, it sounds manual, tedious, and unfruitful. After all, hacking away at rock walls for hours on end hoping to find gold sounds like a lot of work for a very small reward. Data mining, however, is quite the opposite. Without doing much work at all, you can reap rewarding results. And that's because we have modern solutions which do it for us. These softwares can sift through terabytes of data within minutes, giving us valuable insights on patterns, journeys, and relationships in the data. So let's dive into what data mining is, how we do it, and what its examples look like. What is data mining? Data mining is a type of analytical process that identifies meaningful trends and relationships in raw data, and this is typically done to predict future data. Data mining tools comb through large batches of datasets with a broad range of techniques to discover data structures, such as anomalies, patterns, journeys, or correlations. Though it's been around since the early 1900s, the data mining we know and use today comprises three disciplines. The first is statistics, the numerical study of data relationships. Secondly, we have artificial intelligence, the extreme human-like intelligence displayed by softwares or machines. Last but not least, we have machine learning, the ability to automatically learn from data with minimal human assistance. These three elements have helped us move beyond the tedious processes of the past and onto simpler and better automations for today's complex datasets. And in fact, the more complex and varied these datasets are, the more relevant and accurate their insights and predictions will be. By unveiling structures within the data, data mining yields insights that can then be used by companies to anticipate and solve problems, plan for the future, make informed decisions, mitigate risks, and seize new opportunities to grow. What are the steps in data mining? The overall process of data mining generally consists of 6 steps. The first is outlining your business goals. It's important to understand your business objectives thoroughly. This will allow you to set the most accurate project parameters, which include the timeframe and scope of data, the primary objective of the project in question, and the criteria needed to identify it as a success. The second is understanding your data sources. With a deeper grasp of your project parameters, you'll be able to better understand which platforms and databases are necessary to solve the problem. Whether it's from your CRM or Excel spreadsheets, identify which sources best provide the relevant data needed. The third is preparing your data. In this step, you'll use the ETL process, which stands for extract, transform, and load. This prepares the data, ensuring it is collected from the various selected sources, cleaned, and then collated. The fourth is analyzing your data. At this stage, the organized data is fed into an advanced application, and different machine learning algorithms get to work on identifying relationships and patterns that can help inform decisions and forecast future trends. This application organizes the elements of data, also known as your data points, and standardize how they relate to one another. For instance, one data model for a shoe product is composed of other elements, such as color, size, method of purchase, location of purchase, and buyer personality type. The fifth is reviewing the results. Here, you'll be able to determine if and how well the results and insights delivered by the model can assist in confirming your predictions, answering your questions, and achieving the business objective. And last, we have deployment or implementation. Upon completion of the data mining project, the results should then be made available to the decision makers via a report. They can then choose how they would like to implement that information to achieve the business objective. In other words, this is where insights from your analyses are applied in real life. Without proper data management and preparation, data mining could actually work against you by providing inaccurate insights and forecasts. However, when done correctly and by the right software, data mining enables you to sift through chaotic data noise to understand what is relevant. From there, you can make active use of that information in your decision-making. Data mining examples. People tend to assume that more data equals more knowledge, but in reality, it's less about how much data you have and more about what you do with it. Let's look at a few examples of companies who've understood this and have done it right. Through their smart use of data mining, they've come out on top. The first is Groupon. Groupon aligned their marketing efforts, such as ad campaigns and sales offerings, closer to their customers' preferences by data mining 1 terabyte of customer data. This data was analyzed in real time and helped the organization identify emerging trends within their audience segment that they could leverage on. The second is Domino's Pizza. From its point-of-sale systems and 26 supply chain centers to text messages, social media, and Amazon Echo, Domino's Pizza improved its marketing and sales performances while enabling one-to-one buying experiences across various touchpoints. It accomplished this by data mining 85,000 structured and unstructured data sources. Third is Air France-KLM. Air France-KLM created personalized travel experiences for their flyers through building a 360-degree customer view based on data mined from trip searches, bookings, flight operations, website cookies, and social media. Gauthier Lemont, their chief customer data officer, said, "Each and every traveler is unique. With our big data and talent platform, we offer made just for me travel experiences, from purchase planning through the post-flight stage." Well, there you have it. Now that you understand what data mining is, how it works, and the critical role it plays in transforming the way companies do things, perhaps you can start thinking about how these tools can empower you and your teams too. Data mining definitions.
Okay, so it's just a simple discussions and a demonstration of what is data mining. Okay, so now how about the data warehousing? No, so a while ago, no, a data warehouse or data warehousing is the secure electronic storage of information by a business or other organization. No, a while ago, I've mentioned that if you are going to accept payment online, security will be the issue. So data warehousing again is a secure electronic storage of information by a business or other organization. The goal of data warehousing is to create a trove of historical data that can be retrieved and analyzed to provide useful insight into the organization's operations. That data warehousing is a vital component of business intelligence. No? That wider term encompasses the information infrastructure that modern businesses use to track their past successes and failures and inform their decision for the future. Again, data warehousing is the storage of information over time by a business or other organization. Because new data is periodically added by people in a various key departments, such as marketing and sales. No? Because the warehouse become a library of historical data that can be retrieved, no, and analyzed in order to inform decision making in the business. The key factors in building an effective data warehouse include defining the information that is critical, no, to the organization and identifying the sources of the information, because a database is designed to supply real-time information. A data warehouse is designed as an archive of historical information. Because let's say, for example, ATM, no, the automated teller machine. Even you are a BPI holder or you have a BPI account or your card is BPI, you are allowed to withdraw money in other ATM branch or ATM, let's say ATM in Land Bank and so on and so forth. Because they have their own center database. No? They have a data warehouse. No? They have their own, how do you call this one? A storage, no, wherein there is I mentioned real time, no, real time information. No? Now, how data warehouse works. So the need to warehouse data evolved as business began relying on computer system to create, file, and retrieve important business documents. No? So the concept of data warehousing was introduced actually in 1988 by IBM, or International Business Machine. No? So data warehousing is designed to enable the analysis of historical data. Again, create or design to enable analysis of historical data. Comparing data consolidated from multiple heterogeneous sources can provide insight into the performance of a company. So a data warehouse is designed to allow its user to run queries and analysis of historical data derived from transactional sources. Or a while ago, no, the TPS. No, I think you're familiar with MIS, DSS, no, Decision Support System, Expert System, TPS, no, Transactional Processing System, and so on. Now, data added to the warehouse do not change and cannot be altered. So the warehouse is the source that is used to run analytics on past events with a focus on change or changes over time. Now, warehouse data must be stored in a manner that is secure, it must be reliable, easy to retrieve, and easy to manage. So, how will we be able to maintain the data warehouse? Actually, there are certain steps that are taken to maintain a data warehouse. One step is data extraction. No? I don't know if you still remember with your object-oriented subject, the data extraction, which involves gathering large amount of data from multiple source points. So after a set of data has been compiled, it goes through data cleaning, the process of combining through it for errors, and correcting or excluding any that are found. So the clean up data are then converted from database format to a warehouse format. Now, so once it's stored in the warehouse, the data goes through sorting, consolidating, and summarizing, so that it will be easier to use. Over time, more data are added to the warehouse as the various data sources are updated. Let's say, for example, if PTC uses, let's say, for example, a system, no, wherein all your information saved in their databases, no. So every semester it was of course updated, no. So a key book on the data warehousing is, of course, Building the Data Warehouse, a practical guide that was first published actually in 1990. It has been reprinted several times. This will be a book wherein authored by W.H. Emmons, no, the Building the Data Warehouse. So today, business, no, can invest in cloud-based. No, I think you are familiar with cloud. Let's say, for example, you are using, let's say, for example, an iPhone. No, automatic. There are allotted memory capacity. No, even your Gmail. There's, I think, 15 GB, I don't know, or 15 GB allotted for your Gmail account, wherein you could able to save all your data, your video, and your documents into that Google Drive. No? So provided that there is an internet connection, you could able to open all your documents, no? Provided that you have an internet connection. No? So again, today business can invest in cloud-based data warehouse software. Services from different companies. Anong companies ang nag-o-offer ng cloud-based data o cloud-based data warehouse software? Nandiyan si Microsoft, andyan si Google, andyan si Amazon, andyan si Oracle, among others. Okay? Now, how about, a while ago, we've mentioned about the data mining. Okay? So, data warehousing versus data mining, no? So, or data warehousing versus databases. A data warehouse is not the same as database. Take note of it. A data warehouse is not the same as database, because a database is transactional system that monitors and updates real-time data in order to have only the most recent data available. On the other hand, data warehouse is programmed to aggregate structured data over time. Let's say, for example, no, a database, no, might only have the most recent address of a customer. Let's say you have a SNR card, no? So then you visited their account, their counter to update your customer, your address, no? So therefore, a database might only have the most recent address of a customer, while a data warehouse might have all the addresses for the customer for the past 10 years. So data mining again relies on the data warehouse, because the data in the warehouse are sifted for insights into the business over time. So maybe somebody asking about the advantages and the advantages of data warehouses, or tinatawag nating pros and cons. So what will be the advantages, or what will be the pros? No? What will be the cons? No? Now, data warehousing is intended to give a company a competitive advantage. No, it creates a resource of pertinent information that can be tracked over time and analyzed in order to help a business make some more informed decision. It also can drain company resources and burden its current staff with routine tasks intended to feed the warehouse machine. So the corporate finance, now let's say, for example, identifies these potential disadvantages of maintaining a data warehouse. What will be the cons, no, or the disadvantages? It takes considerable time and effort to create and maintain the warehouse. It's costly, of course. Gaps in information, it caused by human error, can take years to surface, damaging the integrity and usefulness of the information. When multiple sources are used, inconsistency between them can cause information losses. Okay? So, advantages: provide fact-based analysis in a fast company performance to inform decision-making. The disadvantages: it creating and maintaining the warehouse is resource-heavy. So, servers, or it serves as a historical archive of relevant data. But let's say if the user input errors, it can damage the integrity of the information archive. Now, advantage, it can shared across key departments for maximum usefulness. But the disadvantages, use of multiple sources can cause inconsistency in the data. And it happens. Now, again, I will show you a video presentation about what is data warehouse.
Warehousing is one of the hottest topics both in business and in data science. But if you're new to the field, you're probably wondering what a data warehouse is, why we need it, and how it works. Don't worry, because in 4 minutes, you'll know the answers to all these questions. All right, first, let's start with the definition. What is the meaning of the phrase single source of truth? In information systems theory, the single source of truth is the practice of structuring all the best quality data in one place. Let's look at a very simple example. Surely it has happened to you to work on a file and to create many different versions of it. How do you name such a file? Well, once you are done, you often place the word final at the end. This results in having a bunch of files with extensions: final, 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 or my favorite, really final, final. If this is you, you are not alone. It seems that even corporations never know where the most recent or most appropriate file is. But what if you knew that there is one single place where you would always have the single source of information? That would be quite helpful, wouldn't it? Well, a data warehouse exists to fill that need. So, what is a data warehouse exactly? It is the place where companies store their valuable data assets, including customer data, sales data, employee data, and so on. In short, a data warehouse is the de facto single source of data truth for an organization. It is usually created and used primarily for data reporting and analysis purposes. There are several defining features of a data warehouse. It is subject-oriented, integrated, time-variant, non-volatile, summarized. Let's quickly go through these one by one. Subject-oriented means that the information in a data warehouse revolves around some subject. Therefore, it does not contain all company data ever, but only the subject matters of interest. For instance, data on your competitors need not appear in a data warehouse. However, your own sales data will most certainly be there. Integrated corresponds to the example from the beginning of the video. Each database or each team or even each person has their own preferences when it comes to naming conventions. That is why common standards are developed to make sure that the data warehouse picks the best quality data from everywhere. This relates to master data governance, but that is a topic for another time. Time variant relates to the fact that a data warehouse contains historical data too. As said before, we mainly use a data warehouse for analysis and reporting, which implies we need to know what happened 5 or 10 years ago. Non-volatile implies that the data only flows in the data warehouse as is. Once there, it cannot be changed or deleted. Summarized once again touches upon the fact that the data is used for data analytics. Often it is aggregated or segmented in some ways in order to facilitate analysis and reporting. All right, so that's what a data warehouse is, a very well-structured and non-volatile de facto single source of truth for a company. If you enjoyed this video, don't forget to hit the like button and share it with your friends. And if you'd like to become an expert in all things data science,
Okay, so that will be an additional input actually about data warehouse. Now, based on the given what they call this one, based on the given course outline, we have also a history of data mining, right? So again, in the 1990s, the term data mining was introduced, but data mining is the evolution of a sector with an extensive history. So no, pero syempre naging familiar sa 1990s. But early techniques of identifying patterns in the data include Bayes' theorem is 1700s, no? And the evolution of regression, that is 1800s. No? So the generation and growing power of computer science have boosted data collection, storage, and manipulation as data sets have broad insights and complexity levels. So explicit hands-on data investigation has progressively been improved with indirect automatic data processing and other computer science discoveries such as neural networks, clustering, genetic algorithms, that is 1950s, decision trees, that is 1960s, and supporting vector machines, that is 1990s. So data mining origins are traced back to 3 family lines: the classical statistics, the artificial intelligence, and the machine learning. Now, what is classical statistics? Statistics are basis of most technology on which data mining is built, such as regression analysis, standard deviation, standard distribution, standard variance, discriminatory analysis, cluster analysis, and confidence intervals. All of these are used to analyze data and data connection. So now, artificial intelligence, on the other hand, is based on the heuristic as opposed to statistics. So it tries to apply human thought like processing to statistical problems. So a specific artificial intelligence concept was adopted by some high-end commercial products such as query optimization modules or relational database management system, or the RDBMS. Now, how about the machine learning? So machine learning is a combination of statistics and artificial intelligence. It might be considered as an evolution of artificial intelligence because it mixes, again, artificial intelligence heuristics with complex statistical analysis, because machine learning tries to enable computer programs to know about the data they are studying so that programs make a distinct decisions based on the characteristic of the data examined. So it uses statistics for basic concept and adding more artificial intelligence heuristics and algorithms to accomplish its target. Okay? So actually we have different data mining tools, no, that we could able to adapt or to use in data mining. Okay? So to give you additional input about the topic, so please do watch this video presentation also.
Data. That word is everywhere these days. Every company is dying to tell you about its big data, data analytics, data privacy, data warehouse, data lake, data. And at the center of the data mania is data mining, the practice of sifting through all those piles of information for insights. Data mining recently made big news with the Cambridge Analytica scandal. The political consultancy reportedly sucked up data about millions of Facebook users without their knowledge, then used it to profile and sway voters in the US, UK, and elsewhere. And similar techniques let companies like Amazon, Facebook, and Google work out what we want to see or buy, sometimes with shocking accuracy. It's a little creepy. It's not just ads and politics either. Data mining allows airlines to predict who's going to miss a flight, it tells big box stores who's pregnant, it helps doctors spot fatal infections, and it's even enabled cell phone companies to predict massacres in the Congo. The power of data mining and the hype surrounding it can make it sound like a magic wand, one that will either save your business or sink democracy. Of course, data mining doesn't really involve any unicorn hair or phoenix tail feathers. It's just applied statistics, searching lots of data points for patterns that humans might not spot. Those patterns are based not on human intuition, but on whatever the data suggests. So sometimes they can seem incredibly subtle or even alien, but there's no more magic in data mining than there is in a weather forecast. In fact, data mining is a lot like meteorology. Meteorologists aim for two things. First, they want to describe patterns in the weather to boil down its massive complexity into a few numbers and equations. And second, they want to predict Tuesday's weather. That's the whole point. Similarly, Spotify's data scientists might be interested in describing medieval rock fans and recognizing them as a group distinct from nerdcore or freak folk fans. Yes, that's a real subgenre. Ultimately though, what's most important to companies like Spotify is predicting what each person wants to listen to. The key with data mining is that it achieves description and prediction not through careful study by experts, but by analyzing large amounts of data. In Spotify's case, that might mean scanning for patterns in genre labels, acoustic attributes, internet reviews, and anything else about each track, plus the age, location, friend group, and other scraps of information about each user. Data mining is more about spotting patterns than explaining them. Of course, the words pattern and data can mean just about anything. There are no clear definitions for data mining, data science, or big data, and they're sometimes used interchangeably with each other or with machine learning. That's why it's so easy to slap these buzzwords onto any project for instant venture capital karma. That being said, a few types of techniques consistently earn the data mining label. The most broadly applicable one is classification, where you try to categorize things. For example, Target famously realized as early as 2002 that they could guess who was pregnant and send them baby-related coupons. That's a textbook classification problem. Target needed to assign each customer to one of two categories, either probably pregnant or probably not pregnant. Classification typically works in several stages. First, each example or instance has to be broken down into a collection of numerical attributes or features. For a store like Target, an instance might be your mom 7 months before you were born. The features would be things like how many bottles of unscented lotion did you buy in the last 3 months? How about in the quarter before that? And likewise for zinc supplements, Asian pears, and every other product in the inventory. The store would also need labels for some chunk of the data, the ground truth about whether those customers were pregnant. Target got those labels from baby registries and due dates customers had shared. Once the data's all lined up, it's time for training. That's where the system tries to tease out patterns from all the labeled examples. Learning to classify is such a basic common need that dozens of algorithms, the mathematical procedures computer programs follow, have been devised for it. Which algorithm works best depends on all kinds of factors, like how many categories there are and how different features are connected to each other. But many classification algorithms are similar in that they treat each feature as a drop of evidence for one category or the other. The features get weights indicating how strongly they boost or weaken someone's chances of falling into the yes category, that they are pregnant, for example. Those weights are what the system learns during training. Basically, Basically, it's figuring out how informative each attribute is. And finally, to classify instances the system hasn't seen before, it puts together all the weighted contributions and maybe stuffs the resulting number through a bit of mathematical machinery to slide it up or down. If the result is negative, that instance goes in the no bucket. If it's positive, load up on those crib coupons. Each individual feature doesn't tell you much. In fact, many turn out to be irrelevant, but together they can be really powerful. Target's approach worked so well that when one customer complained that his teenage daughter was getting coupons for baby clothes, he ended up apologizing to Target. It turned out the company knew about his daughter's pregnancy before he did. Classification is useful anytime you want to tell one group of things from another. Insurance companies use it to guess which elderly patients will die soon so they can start end-of-life counseling. And doctors use it to check whether premature babies are developing dangerous infections, since the classifier can put together subtle disease indicators before humans would notice any signs. I could spend all day listing uses for classification, but it's far from the only type of data mining. One close cousin is known as regression. And no, that doesn't mean deciding you like Limp Bizkit again. In regression, instead of predicting a category, the goal is to predict a number. Take Target again. They wanted to know not just whether each customer was pregnant, but when to send each coupon. So they managed to estimate due dates too. And that's a regression question. How many weeks until the customer gives birth? Regression often depends on dozens or even thousands of variables, the features that describe each example. It finds an equation or curve to fit the data points, telling you how high you'd expect the curve to be given any arbitrary input, or in this case, how far away you'd expect the customer's due date to be. Like in classification, many regression techniques give each feature a weight, then combine the positive-negative contributions from the weighted features to get an estimate. And also like classification, regression is used everywhere. One of the better-known examples is Google Flu Trends. In 2008, it began publishing real-time estimates of how many people had the flu based on searches for words like fever and cough. Regression is also part of predictive policing software, programs that look at historical data to guess how likely a crime is to occur in each area. The third major data mining technique is clustering. As the name suggests, the goal here is to group data points in a way that helps with the analysis. In the marketing world, clustering emerged in the 1980s, well before data mining, with the work of a market researcher named Howard Moskowitz. He struck gold when he realized that there wasn't one best pasta sauce. Consumers showed three distinct types of preferences, and the previously unrecognized group that craved extra chunky turned out to be worth millions. Clustering is often used to analyze market segmentation like this, but to understand how the techniques work, let's take a different example. eBay. On eBay, you can get millions of products, from antiques to zip ties. Even within a single category, like electronics, the selection is overwhelming. So, eBay organizes things into subcategories. But it's a pain for humans to trawl through all the electronics, identify subcategories, and assign every product to a subcategory. Instead, the company can use clustering to automatically group the products. Again, each product first has to be broken down into numerical features, like how many times printer appears in the description, or who manufactured it. The simplest clustering method is to guess how many distinct subcategories there should be, then you randomly lump items together into that many clusters and keep shifting items between groups to make each cluster tighter. In the end, similar products end up settling into clusters together. But we don't have to stop there. The blue and silver versions of the same camera don't really deserve separate listings. They're variants of the same product. So in addition to subcategories, it would be nice to find listings to merge. Sites like eBay can do both simultaneously with a technique called hierarchical clustering. Rather than a single set of categories, hierarchical clustering produces a sort of taxonomic tree. For example, it might find that cameras are much more like each other than like TVs. But within cameras, the DSLRs and point-and-shoots each get their own subgroup, albeit slightly less distinct ones. And within those are many different models, each with a few variants. Companies like Cambridge Analytica use these techniques to look for groups of voters who will respond to the same kinds of advertising. And Spotify can use them to guess who will like similar music. The fourth staple of data mining is anomaly detection. It's basically a special case of classification, identifying instances that are unusual or worrisome. The IRS uses anomaly detection to spot likely tax evaders, and credit card companies use it to flag transactions that don't fit your usual buying habits. It also helps industries with heavy-duty equipment. For instance, power companies and airlines can see when a generator or a jet engine is starting to vibrate differently than usual. Some anomalies can be detected just by looking for deviations from averages. Fancier techniques include looking for instances that don't match any cluster, or comparing instances with the closest other examples to see if their feature values are far off. Finally, association learning reveals which birds are of a feather. The idea is to look through, say, millions of grocery store purchases to see what gets bought together and when. A classic example is the Osco drugstore chain, which once found that many customers bought beer and diapers together on Friday evenings. Contrary to popular legend, the store never acted on this profound insight, but stores regularly use observations like this to optimize their floor layouts and inventory. For instance, Walmart discovered that shoppers buy lots of Pop-Tarts immediately before hurricanes, so it started to stock up. Association learning has broader applications too. Celltel, an African cell phone company, realized it could spot impending massacres in the Congo when everyone nearby started buying prepaid phone cards. So the 5 strategies we've covered, classification, regression, clustering, anomaly detection, and association learning, form the backbone of data mining. What makes them so powerful is that they offer standard mathematical tools you can use for everything from curating Facebook feeds to optimizing store layouts. But that ease of use can also lead people astray. Data mining is just one step in the process of extracting knowledge from data, and it's all too easy to whip out an algorithm without carefully selecting the data, massaging it into the right form, and considering how to interpret the results. Remember Google Flu Trends? It shut down after a few years, but not because the algorithm was broken. Search auto-completion had totally thrown off the data, and engineers had given it too much leeway to interpret seasonal words like snow as evidence of the flu. And then there are the queasy social implications of sharing data in the first place, and of letting companies form such an intimate understanding of our behavior. In other words, the creep factor. So as powerful as it is, the math of data mining is just the beginning. Sometimes the hardest part is all the messy human stuff. Thanks for watching this episode of SciShow. If you're interested in the ways companies
Okay, so I'll give you already about different data mining. No? So to summarize all the discussion about data mining, again, sorry, I have a poor connection. Data mining, again, is a type of database analysis that attempts to discover useful pattern or relationship in a group of data. So the analysis use advanced statistical methods such as cluster, as I mentioned, and sometimes employs artificial intelligence or neural network techniques. So a major goal of data mining is to discover previously unknown relationship among the data, especially when the data come from different databases. Businesses can use this new relationship to develop new advertising campaign or make predictions about how well a product will sell. Governments also use these techniques to discern illegal or embargoed activities by individuals, association, and other government agency. So I think that's it for topic number 1.